All right, so today let's talk about four antiderivative examples. Excuse me. And the first one is fx equals 4x plus 2. So in this part, we're going to use the power rule for antiderivative. What it says like this. If the function fx is x to the power n, also make sure that here n cannot be -1. N is, it can be any integers except -1. Then its antiderivative is going to be x to the power n plus 1 over n plus 1 plus a constant c. Okay, so that's the first formula. So we actually can use that to deal with our first problem here. So as you can see, okay, so 4 is a constant, and then this is x to the power of 1 plus 2 times, well, you can think about it, this 2 is 2 times x to the power of, if you think about into this, right? 2 times x to the power 0, so you can also apply those the derivative power rule. So let's do that, which is 4 times x to the power 1 plus 1 over 1 plus 1 plus 2 times x to the power 0 plus 1 over 0 plus 1, and then plus a constant c. Okay. If you simplify all of this, you will see that this is x squared over 2 times 4, so you have this 2x squared, plus 2 times, actually is x, okay, and then plus c. Okay, and the good thing is, for solving the antiderivative, or later on to figure out the indefinite integral problems, you can always check your answers. If you take the derivative of what you have, and then you make a comparison with the original function. If they match, then yes, your answer is right. And if no, you should rework on your problem. Okay, so, right, the derivative of 2x squared gives us 4x. Derivative of 2x is 2. Derivative of the constant, 0. We're good. Okay. Second one, fx is equal to e to the power of 2x. This, we're going to use another antiderivative formula, which says like this. If the given function fx is e to the power of kx, okay, k is arbitrary constant, then its antiderivative, it equals 1 over k times e to the power of kx plus c. Well, for here, I believe you can set that k is not 0. Okay, it's not 0. It can be positive, it can be negative. Okay, but it's not 0. So from there, we can see that the antiderivative for the second part is going to be, for k is 2 in our problem, so it's 1 over 2 e to the power of 2x plus a constant. And again, if you take the derivative of this, you're going to have fx, the original function, so it is correct. Okay, so this is the second one. Now, look at number 3 and 4. Maybe we take a look at number 4 here. Okay, and you see it's x squared times 1 plus x to the power of -2. Be very careful, guys, when you have a function and you're trying to figure out the antiderivative of that function here. And if the structure of the given function is a product of a couple of numbers, what you need to do is to distribute that expression such that there is no multiplication getting involved. Okay, this is the first thing you have to think about it. And because this is part of calculus 1, in calculus 2, there are gonna be some chain rule idea get involved for solving the integrals and integration by substitution and other techniques. But so far in our course in calculus 1, if we have function like this, we suggest you to distribute the function first and then apply the rules we have to deal with that. Okay, so let's look at number 4. If I do the distribution, so you have x squared, right? X squared times x to the power of -2. You're going to have is x to the power of 2 minus 2. Eventually, you're going to have x to the power of 0, which is 1. So it's x squared plus 1. Okay. And now, look at this, x squared plus 1. To find the antiderivative of this, it's very straightforward. Agree, right? So let me write here. Capital Fx is going to be x to the power of 2 plus 1 over 2 plus 1 plus x plus constant c. And if you simplify, you have x cubed over 3 plus x plus c. Now we're done with this. Okay. Alright, so now let's look at number 3 here. For here, you need actually 2 antiderivative formulas. So given fx equals, let's say cosine x, then its antiderivative is sine x plus c. Okay, so this is the first one. And the other one is given fx equals 1 over x. The antiderivative here, guys, you have to be very careful. It's ln of absolute value of x plus constant c. So, no matter your x is positive or negative, the antiderivative, they exist, and it's both ln of absolute value of x, okay, plus c. So we're gonna use those two to deal with this one. So let's write it out. So the antiderivative for this part, which is sine of x, antiderivative for 1 over x, which is ln of absolute value of x, so it's min of absolute value of x. And for this part, we can use the antiderivative power rule, which is x cubed over 3, and then plus a constant. And as you can see, guys, every time we find the antiderivative for this part, you have an arbitrary constant. Here you have another arbitrary constant. Here you have another arbitrary constant. So in this situation, what we'll do is we'll just keep one arbitrary constant, because you can think about it, the sum of 3 arbitrary constants is still one arbitrary constant. Okay, so that's the explanation for this 4 problems. So I'll stop here.